On today's Do Now, we're being asked to circle the equations that are in slope-intercept form. So we want to remember that slope-intercept form is y equals mx plus b, where we have the y alone, our x term, and then the constant. Okay, 5x plus 2 equals 3y. Nope. Y equals negative 4x plus 2. Yes, that's in slope-intercept form. 2y equals negative 9x plus 1. Nope. Y equals 5 minus 4x. So close. Had we just switched the x term and the constant, it would have been, but technically this is not slope-intercept form. Negative y equals x. Nope, because of that coefficient of negative 1, the y is not isolated. And 6x plus 3 equals 8y. Nope. So our only example was y equals negative 4x plus 2. On page 12 in our booklet, we're going to be introduced to two different types of equations today and learn a little bit more about what slope-intercept form is. So a second form of a linear equation is what we call standard form. You're going to use this more in 8th grade and high school, but it's still important to know what it is and how it differs from our slope-intercept form. An equation in standard form is written as ax plus by equals c. And there's a few rules to proper standard form. It has to be written in that order: x term, y term equal to the constant, but those coefficients and the constant all have to be integers. And the leading coefficient a has to be positive. So if it's not in that proper form, we have to adjust it to make it into proper form. And here's an example. 2x plus 6y equals 10. The form of the equation we're going to see most often in 7th grade, and really most often whenever you're talking about linear equations, is slope-intercept form because it's easier to graph with. Standard form offers some advantages when we're talking about systems of equations and solving them, but slope-intercept form really is better for graphing. One of the directions we see when being asked to put an equation in slope-intercept form is to solve for y in terms of x, meaning get the y by itself. Okay? So we know that form is y equals mx plus b. So today we're going to give a little bit more information as to what the m and the b is. Yesterday, we talked about the m as the rate of change. Okay? And it uses that symbol m, and we use the word slope to refer to it. And later on Friday, our lesson is going to be all about slope. B, what's being added, the constant, what we called our initial value yesterday, is really the y-intercept, the point at which the line touches the y-axis. And here's a perfect example of an equation in slope-intercept form: y equals 5x minus 1. On number 1, we're given an equation: 5 times x plus y equals 20 plus 3x. It's not in any special form, but we're asked to write it in both forms. Okay, so my first step here, we're going to write in slope-intercept form. So I'll rewrite it, and then we'll get working there. And I know I wanted to get it in that y equals mx plus b, where we're isolating y. So that first step is going to be distribute the 5. So we get 5x plus 5y equals 20 plus 3x. Let's subtract the 5x from both sides. Line it up under its like term. We get 5y equals 20 minus 2x. Let's divide both sides by 5. So we get y equals 20 divided by 5 is 4 minus 2/5 x. And as we talked about in the do now, that order is not correct. So let's reorder using our commutative property. So we make it y equals negative 2/5 x plus 4, because that 4 was positive. And now we're in proper slope-intercept form. And from this, I can see, oh, our slope, our rate of change is -2/5, and our initial value, our y-intercept, is 4. And that's the beauty of having that format. We're going to use that to graph later on. Okay, and now let's get to our standard form, ax plus by equals c, where a, b, and c have to be integers, and that a has to be positive. So again, I'll rewrite. Okay. We'll distribute 5x plus 5y equals 20 plus 3x. This time my goal is not to get y by itself. I want it to be that ax plus by equals c, where that constant is isolated on the right side. So I want to get the 20 alone. So I'm going to subtract 3x from both sides. 5x minus 3x is 2x. So that's 2x plus 5y equals 20. We've got all integers. Our leading coefficient is positive, so this is proper standard form. Tomorrow, we're going to look at how do we take something that's not in proper standard form and make it into proper standard form. Okay? One of the other things we wanted to talk about today was a solution to a linear equation. So a solution to a linear equation is an ordered pair when the x and y coordinates satisfy the equation. And to do that, we're almost going to do like a check, a formal check. So number one, determine if the following ordered pair, 10, -6, remember our ordered pair is always x comma y, is a solution to the equation 2x minus 5y equals 10. So we've got 2x minus 5y equals 10. We'll substitute in our values of x and y into the equation and see if it works. So we'll do that. Substitute in. What's x? Oh, it's 10. So 2 times 10, notice we're using our parentheses, minus 5 times -6 equals 10. And we're checking to see. 2 times 10 is 20. -5 times -6 is positive 30. 20 plus 30 is 50. 50 is not equal to 10, so we would say no, 10 -6 is not a solution. Okay, so that's our answer. And that means if we were to visualize, this, if we were to graph, what that tells us is that there's a graph and that the line, and I'm just guessing what it would look like, of 2x minus 5y equals 10 is there and it's graphed, and that the ordered pair 10, -6 would be somewhere not on the line. So not a solution, not on the line. Okay, if it were a solution, it would be a point on that line. Okay, almost like how when we have inequalities, all the points on that line for our inequality when we graph is a solution. All right, so then we have number 2, little different style. Determine the missing value if the ordered pair blank 8 is a solution. So this time it's telling us it is a solution. That is a point on the line. Now figure out what the missing value is. Okay, so remember, we've always got our ordered pairs x comma y, so we know the y value, we don't know the x value. It's a mystery. So we'll take our equation, 2x minus 5y equals 10, and substitute in what we know. We know the y, so we'll substitute that in. So that makes that 2x minus 5 times 8 equals 10. Now we only have one variable, we can solve for that, right? It's just like what we did in October in our algebra unit. So we've got 2x minus 40 equals 10. Let's add 40 to both sides. 2x equals 50. Divide both sides by 2. X equals 25. So determine the missing value. The missing value is 25. So we're going to complete page 13 today for our classwork. There's going to be a little bit, is this linear, is this not, converting to slope-intercept form, determining if an ordered pair is a solution, and then finding that missing value. Definitely want to use these notes today as a guide for those different types of questions. Today's math jokes for Matthew's folks. What do you call dudes who love math? Algebros. Have a great day.